For this lesson, we are going to go over how to solve inequalities. And so now when we start this, it's going to look very similar to what we have just finished doing. We just finished solving regular equations, and these are inequalities, and the process is going to be extremely similar. So let us begin with some definitions. First, an inequality is two expressions separated by an inequality sign. An inequality sign, inequality symbol. These are going to be four different symbols that I'm sure you all have seen. The first one is going to be the less than sign. Words that indicate that it's less than is going to be less than and fewer than. The next is going to be greater than. Words that indicate that are going to be greater than or more than. And then we have less than or equal to, and the words that indicate that are going to be at most, no more than, and less than or equal to. And then we also have the greater than or equal sign, greater than or equal to sign. And the words that are going to indicate that are going to be at least, no less, and greater than or equal to. All right. So, and actually, let me change this color. I want to use a different color besides black. Let's like that orange. All right. When solving inequalities, we're going to solve them like we would in a normal equation. And to do that, we are going to use our inverse operations. Inverse operations. And if you don't know, inverse just means opposites. Our inverse or opposite operations. And the process is going to be very similar, but there is a caveat. That caveat is when multiplying or dividing by a negative number, we have to flip that inequality sign or switch that inequality sign. So if we were, let's use switch that inequality sign. So if we were using less than, it's going to switch to greater than. If we were using greater than, it's going to switch to less than. And that's how we're going to, that's the biggest difference, the only difference when we're solving inequalities, all right? There is also an additional thing to do when working with inequalities, and those are graphing. We're going to start to graph these things. When we go to graph these inequalities, our one variable inequalities will be graphed on a regular old number line. We're not going to get fancy and draw a coordinate plane or a Cartesian plane or anything like that. We're just going to graph them on a number line. And then I'll show you all what that looks like in a little bit. When we're graphing, we want to make sure we're using an open circle for our, let's use this color, for our less than and greater than signs. And then we want to be using a closed circle or a filled in circle for our less than or equal to signs and our greater than or equal to signs. For the open circle and the less than or greater than, those are going to be numbers that are not included in the solution set. They're going to be excluded. They aren't going to be in the solution set. For the greater than or equal to signs, when we graph those are going to be numbers that are included in the solution set, all right? When we go to shade these, the number line portion to finish solving, or to finish graphing, excuse me, we're going to shade the right, shade to the right, shade from the number to the right for anything that's going to be greater than and greater than or equal to. And we shade to the left for numbers or for solutions that are going to be less than and less than or equal to. Oh, I did those backwards, excuse me. They're going to be less than and less than or equal to. And a quick little way to remember this, if you look at the direction the pointy part is facing on each of these, here it's facing to the right, it's facing to the right for these, that's going to be the direction we shade. This is also looks like a greater than sign, and this one looks like a less than sign, the direction we're shading. All right, so these point in the direction that we're going to shade. So much like our solving equalities, how those had properties of equalities, our solving inequalities have properties of inequalities. Our first one, our addition property of inequality, if we have a true statement and we add the same number, add one number to one side, we want to do it to the other side. So we're going to add the same number to both sides of the inequality, or to both sides. I'm going to add the same number to both sides of the inequality. For our subtraction property of inequality, it's going to, for the most part, be the same thing. So I'm going to copy and paste this. Copy, paste. And instead of adding, since we're subtracting, we are going to subtract the same number from both sides. And let me make this font a little bit smaller so it fits in the lines. Let's put it at 14. That's good. And I'll do the same with this so it fits in the lines. All right, great. So with our multiplication sign, or our multiplication property of inequality, it's going to be the same as the other two, but the biggest difference, we're going to multiply both sides of the inequality. So instead of adding, let's change this add to multiply. And then for our division, it's going to be the same thing. I think you guys are probably getting the picture for this part. Our division, we're going to divide the same number on both sides of the inequality. Now, once again, let me reiterate that when we multiply and divide by numbers less than 0, that means that when we multiply and divide by negative numbers, we are going to switch the inequality sign, okay? It's not going to stay the same. So I'll say it again when we have an example down below, all right? So our properties of inequality are very similar, our properties of inequality are very similar to our properties of equality, which is what we did when solving equations, all right? So let's look at an example and use our properties of inequality to see how our steps are justified. So let's look at what we're given, step 1, 2, and 3, and then our final solution. Number 1 says, what property justifies going from our given step, from this portion here, to step 1? And we see that this is negative 11y minus 13 is greater than 42. If I look, I see this minus 13, and if I look at step 1, I see they added 13 to both sides. And so the property of inequality that justifies that is going to be our addition property. Of inequality. All right, addition property of inequality. So now let's look at what property justifies us going from step 1, from here, step 1 to step 2. When we look at these bits, we see that this minus 13 and plus 13, those have canceled. They've added to 0, and then we have this 42 plus this 13. We've just added those two bits together. And so we have just combined our like terms, right? And then if we look at from step 2 to step 3, what property justifies that? The property is going to justify that. If we look at it, we see that this 11y is negative 11y is being divided by a negative 11y. Then we see it happening on the other side as well. So the only property that we have that deals with division is going to be our division property of inequality. All right, and so that's how we use our properties of inequality to justify our steps when solving an inequality. If we look at our solution, we got y is less than -5. And if you're careful, look, you see that this we divided by a negative number on both sides, and this sign flipped. We started with a greater than, and when we divided by that negative number, it flipped. All right, so make sure you're mindful of that. Make sure you're taking care to look for that stuff. All right, now let's go on to number 2. Here are going to be some examples. Here we're going to use some of our translating skills that we saw up above, and we're going to translate these things out, and then we're also going to solve them so we get practice with doing both, all right? So let's read the directions first. It says, define a variable, write an inequality, and solve each problem. Then check our solution. Check our solution. That's going to be an important one. And we covered that in the last unit. So we'll cover it again in this unit. It should be just a little bit of a review for you all. All right. So this says 36 is at least 1/2 of a number. 1/2 of a number. So we know this is 36 at least. Let me look above. Let's go look above and see what at least says. If we see at least, what that tells us the sign's going to be. So if I look over here, I see at least is under, greater than, or equal to. So we know that we're going to have that as one of our symbols in this, okay? Then we have 1/2 of a number. 1/2 of a number. So let's start with 36. We know we're going to have 36 is at least 1/2 of a number. So it's going to be a, can I do the greater than or equal to sign here? Greater than or equal to. I can. Awesome. If you all are using Canva, you can just type in the greater than and then type equal to right behind it, and it'll put it in like normal. At least 1/2 of a number. Half of a number is just going to be, we don't know what that number is, so it's going to be a variable divided by 2. All right. A variable divided by 2. All right. So let's just check ahead, look back just to make sure we got this portion at least. Let's make sure we got that right. We looked up earlier, but let's just double check. Yep, at least is greater than or equal to. It's always good to double check when you're doing these, because if you mess up on that step of translating, you're going to get the final answer wrong. All right, so now let's begin the process of solving. When I go to solve these, I'm going to solve them very much like I would, for the most part, exactly like I would an equation. This looks like it's a one-step equation. I have this x being divided by a 2. So I want to perform my opposite operation to bring that 2 over so this x is by itself. So I'm going to multiply. Use a different color here. I like to do my work in this pink, so I'm going to multiply both sides by 2 times 2 times 2. And when I do x over 2 times 2, that gives me with an, at least with just x, because this is, these 2's divide out to be 1x. I don't need to write 1x. I'm just going to write x. And then 36 times 2 is going to be 72. So 72 is greater than or equal to x. All right. 72 is greater than or equal to x. So it also says to check our solution. When we go to check our solution, this is saying if we choose any number that for x, if 72 is greater than or equal to x, we have to make sure that x is going to be, or x has to be less than. So you see how 72 is greater than or equal to x. So x has to be at most 72. All right, so you got to make sure when you go to check these, you use the right number. So if I use like 4, let's say I used 4. If I plugged 4 in for this equation, let's just put 4 there. 30 is 36 greater than or equal to 4 divided by 2? Yes, because 4 divided by 2 is just going to give me 2. So 36 is greater than or equal to. All right, and that's how you're going to go check when we do the rest of these. So let's look at number 3. 3 says 3/4 of a number is at most 24. At most 24. So let's look above and see what our at most says, which one that's going to be. At most is going to be a less than or equal to. So 3/4 of a number. I don't know what this number is, but we know it's going to be 3/4. So it's going to be 3 over 4 times a number, times a number is at most. And that said it was going to be a less than or equal to, is at most negative 24. So now when I go to solve these, to solve this one, I'm going to multiply by the reciprocal. So instead of, to do my inverse operation, instead of doing it in like 3 or 4 steps, you can do it all at once. So I'm going to multiply by 4 over 3 to both sides times 4 over 3. 4/3 times 3/4 n is just going to give me 1 n. And I'm not going to write that 1 down, just going to write that in. And since I didn't multiply or divide by a negative number, that sign stays facing the same way. It's less than or equal to, and then we have negative 24 times 4 over 3. Okay. When we do that, if you can't do that in your head, go ahead and open up your calculator. I'll go ahead and do that with you all so I can open up my calculator so I can make sure I get this right. 24 times 3 over 4. And when you plug that in, you're going to get an 18. But don't forget that that is a negative 24. So a negative number times a positive number is going to be negative. So we have negative 18. All right. Let's look at number 4. 4 says 4 more than the quotient of a number and 3 is at least 9. So this one has a little bit more going on. 4 more than the quotient of a number and 3 is at least 9. So let's tackle what this has first. 4 more than the quotient of a number and 3. 4 more than is telling me that that's going to be some kind of addition. 4 more than the quotient of a number and 3. And quotient, if we remember back to our lesson on translating, quotient tells us we're going to be dividing. So the quotient of a number and 3, we don't know what that number is. The quotient of a number and 3. And then we have 4 more than this. 4 more than the quotient of a number and 3. So we have that, and then we have that with 4 more than that is at least 9. So let's go look above and see what that at least tells us. What is at least? At least is a greater than or equal to. So we're going to use that symbol. We'll write it out. Is greater than or equal to 9. Boop, there we go, 9. So let's go to solve this. This one is a 2-step equation, all right? So my first step is always going to be to move that. If I don't have to distribute or combine like terms, it's going to be to move that constant term over. So I'm going to move this 4 over by subtracting it from both sides, performing my inverse operations. Pow, pow. Plus 4 minus 4 goes to 0. And what I'm left with is going to be this x over 3 is greater than or equal to, ooh, messed that up, hold on. X over 3 is greater than or equal to, and then we have 9 plus a negative 4 is just going to be a 5. And let me move this up. Actually, I'm going to move this over here. so I have more space to work. All right, and then let's just do a little arrow to show the flow of traffic. So now we have this x over 3 is greater than or equal to 5. And my next step, you all probably know this, I want to get the x by itself, so I'm going to multiply by 3 on both sides. And what I have left, x over 3 times 3 is 1x. I'm just going to write x is greater than or equal to, and then 5 times 3 gives me a good old 15. All right. So now that we've practiced solving these, you all are probably very familiar with it now and realize that it's very similar to solving equations. The part that's going to be kind of new is this part, the stuff in here where we solve them or when we graph them. So we're going to solve these and then we're also going to graph them. All right, I'm going to do the first 2 and I'm going to save the last 4 for you all, okay? So let's start to solve this one. This one says h over 6 is greater than 0. H over 6 is greater than 0. This 6 is dividing this h, so I'm going to do my opposite operation. Pow, times 6 times 6. And what I'm left with is this h on this side. 0 times 6. We all know 0 times any number is 0. So h is greater than 0. So when we draw number lines, you can draw any kind of number line. I like to put my answer in the middle if I'm putting my own things in and just draw these, the ones around it, a negative one and a positive one. And so now if you go and look back above to the notes where we talked about the graphing portion, if it is just a greater than or less than, it's going to be an open circle. So I'm going to draw an open circle. Actually, let's do a different color. Let's do that. I'm going to draw an open circle. And then I'm going to draw my arrow facing, I'm going to shade in the direction that the point is facing. So it's facing to the right. So I'm going to shade in to the right. You could also do it on the number line. I just like to do it above because it seems a bit neater. All right, so let's do number 6. Number 6 says negative 11x minus 13 is greater than 42. So let's start to solve this. This one is not a 1-step, this is a 2-step. So my first step is going to be to move my constant term. I'm going to do that by performing my opposite operation, which is plus 13. And by now you guys are probably experts at doing this. Plus 13, minus 13 plus 13 goes to 0. What I'm left with is this 11x is less than, wrong one. Oh, not less than, it's greater than. And then 42 plus 13 is going to give me a 55. So I have 11x is greater than 55. And I'm not done yet. I got another step to do. I need to get this x all the way alone. I'm going to divide both sides by 11 because division is the opposite operation, the inverse operation of multiplication. And what I'm left with is this x is greater than 5. All right, so let's go ahead and graph that one. I'm going to start drawing with my 5 first, just so I know where I'm at, and then I'll put a 4 behind it so we know, and a 6 in front of it. And now this 6 is going to be, or we're going to have an open circle on this 5, and then we're going to look at the direction. Oh, guys, look, so look, I just caught a mistake that I made. And this is something that you all want to make sure you're doing while you're doing these works. I forgot to bring down my negative sign. So make sure when you are doing your work, you check for that kind of stuff. So if I'm dividing by a negative 11 on both sides, that completely changes what I'm working with. So here I started with negative 11 and I forgot to write it. I wrote it just now. So let's go ahead and divide by negative 11, both sides by negative 11. And when we divide by a negative number, we must flip this sign. We must switch this sign. So instead of it being greater than, it is now a less than sign. All right. It's that easy to just make a mistake with these. Okay. You get in a rhythm, you get going, and then you forget to pay attention to what you're writing down. Pay attention to it so you don't make little mistakes like that. All right. Because it's easy. I just did it. So now that we have x is less than 5, we still have this same setup. But when we go to draw our arrow or shade in our part of the graph, this is less than, is pointing to the left. So this arrow is going to come to the left. All right. And I suppose I'll do one more to show you guys what the greater than or less than equal to portion looks like with it filled in. So let's do number 7, and then the rest will be all for you. Number 7 says 23 is greater than or equal to 10 minus 2x. 10 minus 2x. My first step is going to be to move this 10 over. So switch colors, and this 10 is positive, so I'm going to do the opposite of what positive is, and that's negative. So I'm going to add negative 10 to both sides. 10 minus 10, or 10 plus negative 10, gives me 0. Then I have this 23 plus a negative 10. That's going to be a 13. And 13 is greater than or equal to, excuse me, negative 2x. And so now what I'm going to do is divide both sides by this negative 2, because that's my opposite operation. Pow, poo, pow. Awesome, awesome. There we go. And now we have negative 2x divided by negative 2. It's just going to be an x. And then we have this 13 divided by negative 2. Usually I don't want you all using decimals, but in this case, it's okay because we want to plot these on a number line. So 13 divided by a negative 2 is going to give me a negative 6.5. And since I divided by a negative sign, I have to switch my inequality symbol. So it was a greater than or equal to, now it is a less than or equal to, all right? And then I have this x. So let's go ahead and plot this one. When we plot this, I'm going to start with putting 6.5 or negative 6.5 in the middle, and then I'll put a negative 7 on that side and a negative 5 on this side. And now remember, going to the left is further and further away from 0. So that's why that looks like that, if that's confusing to you all. Okay, so now let's finish drawing the graph. I'm going to put a circle here. Is it open or closed? This has an equal to in the inequality. It's a greater than or equal to, or it's a less than or equal to. So we're going to fill that circle in. Ooh, coloring on this is not the easiest. Fill that circle in, and then we're going to look at which way it's pointing. It's pointing to the left. So we're going to fill in. Oh, careful. So the x, this is saying x is greater than or equal to a negative 6.5. So our solutions are not going to be to the left. Our solutions are going to be pointing this way. X is greater than. Our x's, we want our x's, the x's we choose to be greater than, to be from the side closer to 0, or more positive, I should say. Okay? So when you all are, just a little tidbit, when you all are doing this and trying to figure out which way to make the things point, the graph point, the only way it'll tell you which way it's going to point is if your x comes first. So if it's x is blah, 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 x is greater than, x is less than, x is this, x is that. In the case like I have here, where I have my number first, it's going to be flipped. It's going to be opposite. So there goes a little hint for you. Okay. So go ahead and finish 8, 9, and 10. And if you don't have any problems with those, go ahead and get started on the classwork. If you do, you may ask me. All right. Hopefully that helps and you all are able to get going. Like I said, if you have any questions, feel free to ask. Send me an email if you're doing this outside of the hours. But yeah, go ahead and finish up the last 3 and get started on the classwork.